Okay, these are homework problems for the first section in chapter 2. We're doing lines again, linear equations in two variables. So the first one, let's find the slope. Slope is rise for run, which is y2 minus y1 over x2 minus x1, right? And this is on your formula sheet, so you don't have to memorize this necessarily. Some people like to write, x1, y1 to represent your first order pair, and then x2, y2, so you know not to make a mistake. But either way, you get 10 over negative 3, which in this case is negative 10/3. You could write it as a decimal, but fractions are perfectly fine. Next question, number 2, says, for all pairs of lines defined by the following equations, indicate I if they're identical, P if they're distinct but parallel, N for normal or perpendicular, and G for general. So basically you have to take a look at each line and determine, look at their slope. So the first one has a slope of, right, this one has a slope of negative 3/4. Let's find the slope from the first one. If I solve it for y, I get negative 3x when I move that to the other side. And then if I divide everything through by 4, then I get negative 3/4. So those would be parallel because they have the same slope, so I put a P there. Okay, the next one is a line x equals square root of 2. X equals a number, square root of 2 is like 1.4. So x equals number is a vertical line because y can be anything, but x has to be that number. And then the other one is y equals pi. Y equals pi is 3.14, so it's like a horizontal line that goes through pi. There is one unique intersection point, and they are perpendicular to one another. So we would have to put N for normal. Normal means perpendicular in math, by the way. Okay, the next one, this line has a slope of 1, and this line I need to find the slope, so I'm going to subtract 3x from both sides. I don't care about the 7, that's not going to affect our slope. Our slope's what's attached to x. We divide by 5, and we get y equals negative 3/5. So negative 3/5 is a slope that goes down like this, and 1 is a slope that goes up like this. They're not perpendicular though because they're not opposite reciprocals. So we just enter in G for general for this one. And the last one, this one has a slope of negative 3/4, but this one I need to solve for y. So I have 4y equals negative 3x again. Divide both sides by 4. You get negative 3/4. Now, that's the same slope, so I'm tempted to say parallel, but I should check to see if they're identical. So that 7, if I move that over, would be over here, and that would also have been divided by 4. So they're not identical because they don't have the same y-intercept. When you solve this for y, this equation for y, you get this equation, which does not have the same y-intercept as its original function. So they're just parallel. I should go back and check, though, the first one, because the first one I never checked to see if they're actually identical. So solve that one for y again. 4y equals negative 3x plus 5. Divide everything through by 4, and you get the same yeah, because when you subtract from 5 from both sides, that was a negative. So you get the same exact equation. So these are actually identical. Next one says the equation of a line goes through this point is parallel to this line. We want to write it in slope-intercept form. So we need to find the slope if we're going to make it parallel. So I'm going to solve this equation to find the slope. I'll subtract 5x from both sides. 5y equals negative 5x plus 3. And then I'll divide through by 5. All right, that gives me a slope of negative 1. So my slope needs to be negative 1. So in my equation of a line, I have y equals mx plus b. And my slope is negative 1. Now, I need to find out what my y-intercept is. So I'm going to take the point that they gave me, 5, 1. And I'm going to plug 5 in for x right here. And I'm going to plug 1 in for y. And that's going to help me solve for my b. So that gives me 1 equals negative 1 times 5 plus b. If you then add 5 to both sides, you get the y-intercept, which is 6. And so that's what I need. If I plug that in here, this is my equation of the line. Y equals negative x plus 6. Okay, next question says for this line, find the slope of the line that's parallel. Parallel means same slope, so I just take the slope, which is negative 2. Next one says find an equation of a line that's perpendicular. Perpendicular, you want to take the reciprocal, so it's negative 2 over 1, which the reciprocal of that would be 1 over 2, and you want to change the sign, right? That's perpendicular. You flip it and change the sign, so it'd be 1/2. Next question wants us to find an equation of a line passing through this point and parallel to this equation. So we know our slope needs to be 5. This time I'll use point slope form. It's y minus y1 equals m times x minus x1. Last time I used slope intercept form, but this is fine. I'm going to use my point. This is x1, y1. So it's y minus 2 equals the slope, which is 5, times x minus 3. And I don't know, they probably want us to solve this for y, so if I add 2 to both sides from here, that should work. It doesn't tell me what equation what form it wants this equation in. You could also distribute and put it in slope-intercept form if you add like terms, and that answer would work as well. Next question says, consider the line with x-intercept 2 and y-intercept negative 2. That's this line here. It can be written in slope-intercept form, so it wants y equals mx plus b. Now I can tell you that the slope is rise over run, so it's up 2 over 2, which is just 1. So the slope is 1. And the y-intercept we know is negative 2. So it's pretty easy just to plug in the slope and the y-intercept and get your equation of your line. So this would be 1x, and this would be negative 2 for me. Next question, use the equation right here to determine the slope and y-intercept of the line. So I'm going to put this in slope-intercept form by subtracting 3x from both sides and solving for y. I'll divide through by 6 now, and that gives me y equals negative 1/2 x plus 10 over 6 is really 5/3 if you divide top and bottom by 2. So right away I can see my slope is negative 1/2 and my y-intercept is 5/3. Next question, the equation of a line goes through these 2 points and can be written in y equals mx plus b form. So I'm going to find the slope by doing y2 minus y1 over x2 minus x1, which gives me negative 10 over 7. That's my slope. Now, I need to find my y-intercept, but I guess I'll just use point slope form again, like I did last time, because that way I can just plug in one of these points. Slope's negative 10 over 7. I'll use this point right here. Actually, I'll use this point. It doesn't matter which point you use. X minus 2 and y minus negative 4. Double negatives go positive. I'm going to distribute this, negative 10 over 7x plus 20 over 7. And then I'm going to also subtract 4 from both sides. And I need to add these numbers together, so I'm going to have to get a common denominator by multiplying the top and the bottom by 7, which gives me 28 over 7. So my final answer is negative 10 over 7x plus negative 8 over 7. And there's my slope, and there's my y-intercept. So the next problem is 9. This gives us a point, and it gives us an equation, and it wants us to write an equation that's perpendicular to this line, that goes through this point, but they want us to put that in standard form, and we're done, or I should say general form. So I'm going to first steal the slope from the equation they gave us, which is negative 2y. I'm going to solve for y, so I'm going to subtract 9x from both sides, and I'm going to subtract 6 from both sides. Then I'm going to divide by negative 2. And that gives me y equals 9/2 x plus 3. Okay, so that slope of that line is 9 over 2. I want a perpendicular line, so the slope I'm going to use is negative 2 over 9. I'm going to flip it and take the opposite sign. Okay, the next step, I'm going to write point slope form of a line. And I'm going to use that slope, negative 2 over 9, and I'm going to pick one point, the point they gave us. So x1 is 1, and y1 is negative 1. Now double negatives go positive, so I'll turn this to a plus 1. So we're good. I've got an equation of a line that's perpendicular to this line through this point. The problem is I don't have it in general form. I have to get it in that form. So what I'm going to do is distribute. That gives me y plus 1 equals negative 2x over 9 plus 2 over 9. And I'm going to write this in standard form. So, or general form. I'll move the x over. So the 2x over 9 plus y plus 1 minus 2 over 9 equals 0. All I did was move this over by subtracting it and this. So I added 2x over 9 to both sides, and I subtracted 2 over 9 from both sides. Okay, I'm almost done. The last thing I need to do is combine these two like terms right here. They're just numbers. So to do that, I'm going to multiply top and the bottom by 9 of this, and I end up with this equation, 2x over 9 plus y plus 7 over 9 equals 0. Now here's the equation ax plus by plus c equals 0, where a is 2/9, b is 1, and c is 7 over 9, which is what they wanted. Now, if you try to enter this into Webwork, it's not going to accept 2 over 9 for a, 1 for y, and 7 over 9 for c, because it wants whole numbers. So what we can do to get whole numbers is we can clear fractions. If you multiply through by 9 to clear the fractions now, what you get is this equation. You get 2x plus 9y plus 7 equals 0. So that's the answer they want here. They want the whole numbers. It's actually the same line. If you multiply both sides of an equation, you don't change the equation. So it's the same line. It's just got whole number coefficients, which is what they wanted. So I know it's really picky, but we're going to have to clear fractions here and give the line represented this way. All right, the next question then is another question about slope. This one's different because now we're not finding the slope. They gave us a slope. We're finding one of the coordinates, so one of the points. So it's a weird problem, but we're going to use the slope formula again. It says find this coordinate right here. Slope formula is y2 minus y1 over x2 minus x1. So that's y minus 3 over negative 4 minus 5, and that equals negative 11 over 9, because they told us that's what slope equaled. So I'm going to simplify this and solve for y. This is negative 9 in the bottom. Negative 4 minus 5 is negative 9. And I'm looking at this equation. I want to solve that. So let's see. I can basically, there's different things you can do. I can basically make these both positive because I can multiply both sides by negative 1. I see that. Hopefully you do too. I can also get rid of the 9s, or just multiply through by 9 to both sides. The 9s cancel. And you get y minus 3 equals 11. Add 3 to both sides, and you get y equals 14, which is what they wanted right here. That must be that coordinate in order to give this a slope of negative 11 over 9. Next problem says, are the lines below parallel, perpendicular, or neither? So I'm looking at these two lines, and I'm looking specifically at the slope. The slope of the first line is 5, and the slope of the second line is obviously what's attached to x here, which is 1/5. And these lines are neither. Okay, if they were parallel, they'd have the same slope. If they were perpendicular, they'd have opposite reciprocal. These have reciprocal slope, but they're not opposite. One would have to have a negative sign. So they're neither. Okay, the last one then says the graph of this is a straight line with a slope of, well, the slope's m, obviously. Any line perpendicular to that graph will have a slope of opposite reciprocal, so it would be 1 over m, but negative. And then it says the graph of the inverse function of f is a straight line with slope. And the last part, this inverse, we're going to cover that soon this class, but we haven't covered it yet. So if you don't do this last part and don't get it right, I'll still give you credit for this in the homework, and you will not be tested over that right now. The first two questions are great questions, but the last one is just something we haven't covered. But we will, and when we do it, to find the inverse, what we do is we switch x and y. We'll do this later. And we solve for y, because that's not the inverse now. To do that, you subtract b, and you divide by m, which I can simplify as y equals x over m minus b over m. So that's my inverse function, which we'll usually write as f inverse, like that. We'll talk a lot about inverses, what they are, and what they're useful for. But for right now, the slope of the inverse function will be 1 over m, right here. And like I said, not something you need to know for now. I hope this helps.